All right, so these are the notes that you guys are going to be copying on Friday with the sub, and all I'm doing tonight is showing you a video of the notes and narrating them. I'm not expecting you to be copying them right now. It's really just for you to hear me explain the notes, and then on Friday, when the sub is there, she's going to have you copy them. So these are just notes on parallel and perpendicular lines. Parallel lines, if you remember, always have same slope, different y-intercept, right? Perpendicular lines have slopes that are opposite reciprocals. So I've showed you a couple of examples here where we have parallel lines, and of course they both have a slope of 2. And then the perpendicular line, the two of them, one has a slope of 2/3, the other one has an opposite reciprocal of -3/2. So we just take it and flip it. One was positive, one was negative. So then what you're going to have to do for your homework is going to be comparing equations. Are they parallel or are they perpendicular? We always have to be able to determine their slopes, right? That's the key to this whole thing, is to be able to tell if they're parallel or perpendicular, is to look at their slopes. So what you're going to notice now that's a little bit different from what we've done in the past is we're going to get equations that are in different forms. For example, in this equation, the example here is in standard form, and we're comparing it to the other one, which is in slope-intercept form. So what makes it difficult is we can't see the slope in the standard form. So we're going to have to change the way that it looks. And so what do? We end up just changing it from standard into slope-intercept form. And sure enough, it has a slope of -2. The other equation also had a slope of -2. So now you can see they're parallel, right? Okay, now we look at the next page, and it's got some notes here as well on writing the equation of a line that contains the point -2, 3 and is parallel to this other point. So if it's parallel to this other line, so it's going to be parallel to this guy, that means it has to have a slope of 5/2, and it has to go through the point -2 and 3. So the part of this lesson that you'll be copying down is for you to see that there's two ways that you can work this problem out. You can work it out by using y equals mx plus b, or by using point slope. It doesn't matter at this point. Now you're kind of doing what you feel most comfortable with. And you're going to see that after you do all the work, you end up with the exact same equation from doing it either way. Then we get down to one more example. It says to write an equation that's perpendicular to the one equation there that's in slope-intercept form and contains the points 6 and 2. So now we go back to the same idea. This guy here has a slope of -2. The perpendicular equation would have to have a slope of +1/2. So now we have two ways we can do this. We can either use the slope-intercept form over here, or you can do it in point slope over here. Once again, you'll notice that you'll come up with an equation down here. They're both the same. It's just doing things two different ways now. And indeed, this equation is perpendicular to the other one because its slope is 1/2 in either equation, and the one that I used that had to be perpendicular to had a slope of -2. So that's it. So tomorrow you guys will be copying these notes with the sub, and if you have any other questions, you can rerun this video and hopefully it'll help.